Echoes from the Eons, Episode 5, Land of Jewels, produced by the National Dinosaur Museum, Canberra. Australia is a large country, known for its breathtaking and varied landscapes and natural features. It is rich and abundant in many ways, but it is the bounty beneath the ground that defined so much of its development after its opening up in the early 1800s. The mining industry is today surrounded by strongly conflicting opinions and reasonable concerns about its future as both environmentally and economically viable. There is no escaping, however, that it has played a powerful role to date. Today, 9 of our top 15 national exports are resources pulled from the ground. Those resources have changed with time, but 2 of the oldest, the most caught up in the Australian story, are the demand for those precious and beautiful natural treasures, gold and opal. Of the 2 resources, it may come as a surprise that opal was discovered first. The first gold rush began in 1851, but the opal rush preceded it by a few years. It is an unusual stone compared to other precious gems like emeralds, rubies, or diamonds. These jewels are prized for their strength, striking clarity, and the way that they can be cut to angle and play with light. By comparison, opals are soft, and although capable of striking iridescence, their colour and value doesn't come from large, unflawed open space, but densely layered pieces of contrasting elements. Opal is built differently to other gems, and is formed from silica spheres tightly packed into a 3-dimensional grid, accompanied by a small amount of water. This water retention between the spheres means the stone is classed as a mineraloid, rather than a true mineral like a diamond. The individual spheres themselves split white light into the various colours of the light spectrum. Larger spheres are able to refract a wider number of colours, and the small spheres will produce only blue or green. In addition to the size of the spheres, the observable colours are determined by the spacing between and orientation of the layered planes in respect to the available white light. The story of opal is the story of water. The silica that forms into precious opal is released into the groundwater by the erosion of terrestrial rocks during extreme weathering processes. This solution is then carried along the water to fill cracks and fissures in other rock layers, where it sets into a gel, along veins or lenses. A vein is a fairly familiar term, wherein the ore is disseminated with definite boundaries against the surrounding rock. Lenses are similar, but form with a body that is thick in the middle and thins out towards the ends. Because the silicate solution is aqueous, it often forms in layers, and these layers can have an effect on the end visual form. If a red layer is present, a rare and highly valuable element, it can indicate that there was a stronger evidence of gravity in the depositing process, as such a layer is always exceptionally thin. Silica is a fairly common natural substance, but it doesn't always opalize, and there are different schools of thought on the nature of opal silica. Some suggest that it may be an organic form of silica originating in rotting feathers, bones, or other organic matter, and that perhaps the silica in question was once part of a kaolin clay. As the clay dehydrated, the silicates may have had the opportunity to develop into opal. As the solution fills faults and fissures in the ground, it receives a slight electrical charge, produced by the friction naturally occurring in the ground's fault, allowing the growth of the amphorosilica structure that is precious opal. Although all types of opal share the same optional background colours, white, grey, or most rare and precious black, only precious opal enjoys that prized iridescence. The majority of the opal in any given deposit is of the non-precious variety and is referred to as potch. Opal was first mined in Hungary and Czechoslovakia, and the first ever recorded knowledge of one is in 250 BC. It is also found in Brazil, Mexico, Honduras, Western United States, and Ethiopia, but Australia dominates the world's supply. A massive 95% of the global supply is found on the Australian continent, including the prized black opals and the world's only opalized fossils. In Australia, these deposits are usually found in sedimentary rock, sandstone and mudstones, below the surface, and natural outcrops rarely appear. Although this is below the surface, the deposits are extremely shallow. Prospecting tunnels only need to be sunk to a depth of around a metre. It is the Australian red centre that harbours this treasure trove, and it is the regions within the long dry Great Artesian Basin that prove them most abundant. This environment is unparalleled elsewhere on the planet, but fascinatingly is the most similar earthly example to the conditions present on Mars. The basin and the Martian surface have many analogous features, sharing similar volcanic lithologies, and absent of significant carbonate, similar secondary assemblages including opaline silica, similar acidic oxidative weather, which has been driven by similar surface drying out, and simple, striking colour. The Great Artesian Basin is believed to be the only place on Earth to have experienced the kinds of acidic weathering on such a grand scale as to be comparable with Mars. Associate Professor Patrice Gray of the Sydney University has spent the past several years exploring the connections between opal development in Australia's Red Centre and the environment on Mars, where in 2008 NASA had recorded finds of non-precious opal deposits. It has been suggested that part of the reason the concentration of the world's opal is so localized is a result of the unique scale and severity of the drying out of the basin 100 million years ago, in which the inland sea regressed in an extraordinary episode of acidic weathering. This dramatic weathering may have been triggered by sulfuric acid released by exposed pyrite crystals. The journey from ore to ornament has seen little changes over time. First, a prospective area will be drilled with 1 metre vertical shafts using a bucket drill. The sample extracted will then be sorted through for opal fragments to see if the lode beneath has the potential to be economically viable. Recently, this process can be enhanced somewhat with the discovery that the opal level and the ore itself is slightly radioactive. This means that if the drilled sample fails to bring precious opal fragments to the surface, evidence for its presence may still be detected through gamma-ray logging of the holes. Once a location has been identified as suitable for mining, the excavation process can begin. Traditionally, this involves sinking a shaft and tunneling along the level with picks and shovels, and winching the material to the surface. This process is now highly mechanized, but often operations are still managed by small leases and claims, rather than the huge conglomerates you see in other industries like diamonds. In Australia, there are some differences in mining procedure to fit with the relevant state regulations. For example, in New South Wales, only underground mining is permitted, while Queensland sees more open-cut mines. Only a fraction of the excavated material, even from the best mines, can be sold as opal. From a load of material around 5 to 10 cubic metres, the usable amount recovered would easily fit in a shoebox. Once retrieved from the ground, the material is then processed by hand, according to size and colour, before being sent to refinement. The most valuable pieces get cut and polished for jewellery pieces, and the less valuable opal rock may find its way into use in carvings, tiles, or decorative elements in furniture. Opal used in jewellery can be divided into 3 groups: solids, doublets, and triplets. A solid is fairly self-explanatory and is the most expensive of the 3. A doublet is a slice of opal stuck to a stone base. This provides the thin opal layer with strength and the physical shape to allow it to be safely set into a jewellery piece. A triplet, the least expensive of the 3 options, includes a clear plastic or glass cap on top of the thin and fragile opal layer, helping to protect it and to give an illusion of depth. It is something of a myth that opals will be damaged if they come into contact with water or perfume during wear, and this is usually got to do with triplets. While a solid opal would not be affected, it is possible for these things to get in between the clear cap and the opal layer on a triplet and turn the piece cloudy or dark. It was some time, though, before there was a market for this shimmering, multicoloured stone. While not entirely unknown, the initial reaction to Australian opals was cool. It can be difficult to set, as it is soft and crushable, and the way the stone dealt with light and colour was unfamiliar, resulting in reluctance among jewellers in Europe. It also suffered something of a bad reputation from the superstitious. Although prized by royals in antiquity, by the end of the Middle Ages and onto the 19th century, the stone was associated with being a poor omen, bringing bad luck or death. Opal, especially white opal, was considered a particularly inauspicious choice for a wedding ring, unless apparently the bride was born in October, a month whose birthstone is the opal. Some more contemporary superstitions give the stone healing properties, and in parts of Asia it is associated with bringing good luck in business. It is interesting to note that even as beliefs around the stone have changed over time, the preference for the expensive black opals as being lucky and prosperous over the more common white as unlucky or less powerful has remained consistent. Australia's other great treasure has always been popular. Gold is our 4th biggest export among physical resources and has a variety of important uses. While most people understand that gold is valuable, beyond its use as a way of backing up currency and jewellery, its other uses are less well known. It is a good conductor of heat and electricity, and because it doesn't tarnish or oxidize like other metals, it is particularly well suited to use in electronics, on circuit boards and connectors. Almost all advanced small electronics will contain some amount of gold, and some larger devices, such as televisions and computers. It reflects infrared radiation and can be used on buildings or even spacecraft to help shield against the sun, or in infrared telescope lenses. Gold has also enjoyed a long history of medical and dental applications and is used in treatments of cancer and arthritis. As it is non-reactive, it is an especially reliable material to use in a lot of medical equipment, life support devices, and some surgical tools. Incorporating gold into glass is an ancient technique to color the glass red, and in the form of gold leaf, it has been used to dress roofs, buildings, and statues for centuries, providing not only a spectacular visual, but corrosion-proof weathering. Gold has been a highly sought-after element for thousands of years. It is soft and malleable, resistant to most acids, and highly reflective. The color of gold is related to its purity, though few people will encounter true, pure, or 24-karat gold. Instead, most people will be familiar with gold alloys, paler and often mixed with silver, a metal with the same atom structure and nearly identical sized atoms. White and rose gold are not naturally occurring, but rather man-made alloys designed to alter the color and increase the metal's hardness. Carats is the measurement most often used in jewelry, while the mining industry will prefer a scale of fineness, or parts per thousand. Fine gold, or pure gold, will be 1,000 parts, and this corresponds to 24 carats. Gold is widespread in the Earth's crust. While overall concentration is quite low, rich deposits have been found across all continents. As with opal, water is an important part of the formation process. Gold is transported through the crust of the Earth, dissolved in warm or hot salt water. These waters are generated in massive quantities deep below the Earth's crust, and as the water-bearing minerals dehydrate, any gold present in the rocks is compressed and sweated out into solution as complex ions. In this dissolved state, the gold, along with other elements, is taken to wherever the fractions in the rock allow water to pass, generally upwards to cooler regions and lower pressures. Eventually it becomes insoluble and starts to crystallize, most often surrounded by quartz. Gold deposits did not all form around the same time. The deposits of Western Australia are older than those found in Victoria by about 400 million years. All gold has a crystalline structure. However, the different forces of the environments that form the ore can have an effect on the style of its final form, following a cubic system. The most sought-after form of all is the golden nugget, and while these have been found throughout Australia and the world more broadly, the ones found in the state of Victoria were especially sizable and abundant. It is in search of these that thousands of hopefuls migrated to Victoria, where more than 1,200 nuggets had been recorded prior to 1910, all larger than 20 ounces. Like with great jewels, the largest of these were given names and kept as powerful mementos of wealth and prosperity. At an incredible 72 kilograms, the greatest of all these in Australia, named the Welcome Stranger, was discovered near a bush track in 1869. Nearly all specimens of any great size were melted down immediately, both as much easier commodity to sell and to prevent theft. In a notable case, weighing 256 ounces from Wedderburn, the Pride of Australia nugget, which was purchased by the State Bank of Victoria as a contribution to the state's 150th anniversary, was stolen from the Museum of Victoria, where it was on loan in 1991. There is today a growing market in gold specimens as collectibles and even infamous examples of forged or fake nuggets, such as the Yellow Rose of Texas. This fabricated 12.4 kilo nugget was later sold to the Perth Mint and melted down, but the story shines some light on the complicated nature of the differing systems of values surrounding gold, gold use, and status. Gold was discovered in Australia in 1851. The gold rush that followed would prove to be one of the most influential stages in Australia's colonial history, and it is no secret that the small agricultural and penal colonies were ill-equipped for the ambitions of its now swelling population. Life on the goldfields was hard, often lonely, and expensive. Alfred Clark, writing in the Geelong Advisor, 1851, describes the prospectors thus: "A gold digger must be a jack of all trades. He must be able to strip bark, fall a tree, and saw it, dig sods, make embankments, put up a hut, mend your clothes, draw firewood after chopping it, bake, boil, and roast, use a pick and spade, delve, dig, and quarry, load and unload, draw a sledge, and drive a barrow, cut paths, make roadways, puddle in mud and splash in ankle-deep water, with occasional slushings from head to foot, bear sleet and rain without flinching during the day, and sleep in damp blankets during the night, thankful that they are not entirely saturated. If ye can do all this, and have the spirit enough to attempt it, and endurance enough to carry it on for 3 months, why there is gold and rheumatism in store for you. Oftentimes, the people who made the most profit on the fields were the merchants and traders working around the diggers. The pool of gold brought thousands of opportunists at differing levels, and the society around them underwent a substantial restructuring and growth. Confidence in the gold rush was accompanied by a flourishing development in the metal crafts, as European goldsmiths sought patronage in Australia, producing original and ornate objects, often with motifs of nature, flora, fauna, and later, indigenous peoples as well. The increase in capital facilitated growth in industry, agriculture, commerce, and arts, helping to produce a more stable middle class, which in turn could support social institutions, universities, societies, and sporting competitions. In particular, the opulent style of trophies and jewellery commissioned for early agricultural societies and sporting associations would become emblematic of 19th century Australian gold and silver craftsmanship, although little of it survives today. There was a prevailing attitude of hope and personal opportunity that was distinct from the experience of gold mining in other countries and other ages. The individual digger was not really a thing before the 19th century. Traditionally, gold was mined on behalf of the monarch or the church, and likewise in the colonial world, the industry was still centred on profit for a more distant power. In Australia, still considered by its new arrivals as a blessed terra nullius, wealth was up for grabs. That sense of opportunity and the recognition of the tremendous efforts to succeed was celebrated with fierce pride. The 1850s saw the arrival of a distinctive type of jewellery known as goldfields or digger jewellery. Often taking heraldic form, these ornaments idealised what it meant to be a gold digger, or an argonaut as they were sometimes called. These pieces could be rings or pins, but most often were brooches. And the more elaborate examples come from the earlier period, when alluvial gold was more accessible. Often they were commissioned by the digger as a memento of success to give to their wives or sweethearts. Goldfields jewellery was usually made up of a selection of native plant motifs surrounding the important tools of the gold trade: buckets, shovels, winches, picks, and pistols. Towards the later part of this stylistic period, miniature nuggets would be set as a feature, much as one would set a precious stone. As with so much of the fine metalwork from this period, most of it has been melted down and reused in the years that followed, but the few examples that remain of brilliant gold and silver celebrations of mundane rural life are a fascinating glimpse into the past. It is important to note that the discovery of gold and opals for mining purposes was not truly the first time these resources had been found in Australia. There are colonial reports of small gold finds before the beginning of the gold rush, and there are a range of oral histories and Dreamtime stories from First Nations people explaining their creations or importance. The locations of gold resources were often known to Indigenous peoples from their histories, and they are frequently recorded as being integral in helping prospectors find new claims, and even trading gold whose locations they did not disclose for goods such as tobacco. Andamuka in South Australia is an important site in the history of opal mining and rests on Kuyani tribal land. There were natural outcrops of opal found here, an exceptionally rare occurrence, and they are a sacred place reserved for ceremonies and traditional teachings. Notable opals from the region include the Adamuka opal, an enormous, palm-sized oval cut stone which was awarded to Queen Elizabeth II on her first visit to Australia, and the Adiman plesiosaur, which is the first known opalized fossil. Further north in Queensland, the Wankamara people have an origin story that ties gold, opal, and fire together as the gifts of exceptionally powerful pelican spirits that turn the land from being barren and inhospitable to rich and plentiful. The uses and attitudes towards gold and opal, the call for sustainable mining practices and greater environmental consideration will have an effect on the future of these resources, among others. Undeniably beautiful and intimately connected to ideas around status, success, and value, they will remain an important feature of both Australian and global society, although the ways they will change and adapt with that society are unpredictable. These reflect a social history much older and far more complex than anything that can be confined to a single continent, and are, of course, only two of the precious resources that Australia is fortunate to have in this ancient landscape that truly is a land of jewels. The National Dinosaur Museum hopes you've enjoyed this episode of Echoes from the Eons, supported by the ACT Government through the Where You Are Festival 2020, produced by Events ACT. This episode has been written by the National Dinosaur Museum, with thanks to Brittany Burgess, and has been voiced by Samantha Chester. If you are interested in learning more about opalized fossils, take a listen to our earlier episode, Australia's Shadows. If you have any questions or suggestions for an episode topic, leave us a message on Facebook. Check out our website or follow us on Facebook for more great content, or better yet, come visit us at the museum.